All right, hello algebra. Today we are going to do pages 19 and 20 in our condensed packet. So day 6 is the day where we change from stats to graphing. So we're going to graph different functions and just see what effect adding and subtracting numbers inside and outside have on the actual graph of the function. All right, here we go. Exercise 1. Graph and label the parent function. F of x equals x squared. So that's the parent function. Nothing's happening to that function. That's the most basic parabola we could have. How do I know it's a parabola? It's an x squared. It has a degree of 2. So I have my calculator out, as you can see. So just to recap, we're going to y equals. I'm putting in x squared, and I'm going to go to the table. And I'm looking for the turning point, and look at that, my table is already set up nicely. I can see the turning points at 0, 0. I see how symmetric the y values are. And I just picked 5 values, and I already wrote that table down just to speed this up a little bit. And you can see that I went from -2 to 2. I also plotted the points and made a parabola. And you can see that I labeled it f of x. This is extra important here, because of the fact that we're going to be doing another graph on the same set of axes, another function on the same set of axes. Okay, so there's our standard parabola. Its vertex is at the origin. It's symmetric with the y-axis. That's just our standard parabola. Now I'm going back to the calculator. You can see I'm going to go back to y equals. I'm going to get rid of what we had for f of x. I'm going to put in parentheses x plus 3. I'm going to close that set of parentheses, square it, come back down, and do -2. So that's what they have for g of x. If you're following along in your notes, you would obviously pause it, get your f of x graphed, and then come back and unpause it. So g of x is x plus 3 squared minus 2. You can see I've typed it into y equals. I am going to go second graph, which brings me to the table, and now it's all over the place. So I'm going to scroll up here. As soon as I scroll up, I can see that my turning point's in there. So I'm going to get a nice table. How can I tell my turning point's in there? Because I see -1, -1 on either side. What number is that? 2, 2, 7, 7. That nice symmetric looking y value is where, or y column is where I know my turning point is. It's right in the middle there. Okay, I already wrote this table down, so you can go ahead and jot that one down. I'm going to plot it with you. I just went from -5 to 1. We're really focusing on where the turning point is. And I'm going to plot these points. 1, 2, 3, 4, 5, -5, 2, -4, -1, -3, -2, -2, -1, and -1, 1, 2. Okay. Trying to make that curved shape. Make sure it's not straight. That's a different graph that we'll see. And there's my other parabola. Okay, so this whole rest of the packet's really going to be talking about, okay, well, what happened from here to here? Okay, we went, if you're looking at the pink one, the original one, f of x that I drew, it's at 0, 0. We moved left and down. Okay, and those numbers are not random. They certainly relate to the numbers in the equation. All right, I'm looking at the follow-up questions, and I'm going to say, just highlight here that what are the roots of f of x? What's the domain of f of x? What's the range of f of x? Those ones are all asking me about my original, the pink one, the f of x. I'm going to highlight in yellow the questions that are asking me about g of x. Okay? And we'll answer those before I get to the last two. What are the roots of f of x? Well, this is easy to do for f of x because looking at it, the only place it crosses the x-axis is at x equals 0. G of X, I don't have any nice zeros in my table. If I did, if I had a couple of zeros over here, I would be like, okay, it crosses the x-axis at, you know, this x value and this x value, wherever I saw a zero here. These are not nice numbers, so if this was back a unit or a couple of units, we would be setting it equal to 0, using the quadratic formula and finding it. I don't really want to get that in depth here. So I'm just going to go with an approximation for this one and say that the zeros are approximately -4.5 and approximately, and this is me really just eyeballing it, -1.5. Okay. All right, what is the domain? Here are the really important questions relating this graph to that graph. What is the domain of our original? The domain of our original is -infinity to infinity. I always like to put a D there for domain. This guy's going to go left and right forever. It will span the entire x-axis. What's the range of f of x, our original? Well, it's not going to span the entire y-axis. There's no values down here. The lowest y value that it will output is 0. So for my range, 0, I want to make sure that's included because I certainly can output 0. If I plug in 0, I output 0. That's the lowest number I'm going to output. All of the outputs over here are going to go up. All of the outputs over here are going to go up. 0 is the lowest output. Moving to the graph of g of x, so the one that was moved around. What's the domain of g of x? Well, it's still a parabola. This should be your answer for all parabolas is domain -infinity to infinity. It's the range we got to be careful with now that it's moved because it actually does go into the negatives a little bit. What's the lowest y value I see? -2. And then it does go up forever, just like any other facing up parabola, so it goes up to infinity. -2 is the lowest output. All the other outputs are going to be higher than -2. What happened to the graph of f of x to become g of x? As I said, it moved left and down, but I want to be specific about that. It moved left 1, 2, 3 units. And down, and again, I'm just comparing turning point to turning point, down 1, 2 units. Okay, what's the turning point of g of x? Well, the turning point of g of x is -3, -2. That's not random, okay? If I look back up here, you can see the number 3 and the number 2 in the actual equation. So here's what I want to point out. That on the inside of the parentheses, and I'm just going to make a set of parentheses. Inside the parentheses, we have an x plus 3. On the outside of the parentheses, we have a -2. And here's what we need to note, and this idea will be repeated a lot. The number on the inside, and I'm going to put, oops, sorry about that, with x. Because this number is considered to be with x. It's x plus 3 on the inside, and then it's squared. So the number on the inside with the x moves the function horizontally. So left or right. Oops. Change colors just so this is a clear second piece of information. Number on the outside So now I'm talking not with the x. Like the 3 was with the x. Now I'm talking about the number after the parentheses, after the squared, this number that's just added or subtracted on the end. That number moves the function vertically. So now we're talking up or down. And this information will get repeated over and over again, but just to point out, the number on the inside, typically plus is thought of as, right, but this is going to be the opposite movement. So a positive 3 moves it left. The number on the outside, that is as is. So a negative 2 does move it down 2. And we're going to do a bunch of examples, but this is really the general piece of information you need to get from that. So when I look at this, I know that the vertex for this guy is 0, 0. When I look here, I know I'm moving it left 3, down 2. And if I'm moving it left 3, oops, pointing to the wrong thing. If I'm moving it left 3, down 2, then my new vertex is going to be at negative 3, negative 2. Okay, moving to the next page. And we have a different function just to see that this is not just for parabolas. Okay, I'm coming back to my calculator. I'm going to go back to y equals. I'm clearing this out. And the original function, the parent function, is going to be regular old square root of x. So your square root's going to be right above the squared. So I'm going to go second square root. I'm going to put an x in there. And I'm going to go to my table. Oh, I see lots of errors. Well, that's because the square root graph, regular old square root, starts at 0. It only gives me positive numbers. So I'm going to pick and choose. Now, you can put in a bunch of these decimals. I'm going to pick and choose nice values. So, for instance, I'm going to start at 0 because I can see a nice point there, 0. I see that 1, 1 is a nice point. Okay? Now, I'm making up my own rules because I'm allowed to, but if they told me I had to plot a bunch of points, I would estimate these. I'm going to pick nice numbers. I see 4, 2 is a nice point, so I'm going to put it in my table, and I'm going to go in order and keep scrolling down. These are all these long decimals. Oh, there's another nice point. 9, 3 is another nice point. The next nice point I'm going to come across is going to be 16, 4. That's as many as I'm going to put in my table. And then you can kind of get a gist of what it looks like. If I go to graph, you can see there's no graph over here. This guy has an end point. It doesn't have a turning point. It just has an end point. That's a key feature of the graph. So 0, 0, 1, 1, 1, 2, 3, 4, 4, 2, 9, 4, 5, 6, 7, 8, 9, 1, 2, 3. That's as many nice points as I'm going to get here. And again, it's a curved graph, and it does have an arrow on the end. This is like if I took a parabola, got rid of half of it, and turned it on its side. That's what shape we're talking about here with a square root graph. Okay, there's f of x. Maybe I'll go through, I think I'll go through and I'll do the questions about f of x real quick. There's just 2 right here. Well, I'm only looking at that one. What's the domain? Well, this is not going to be all real numbers. The domain of f of x is going to be 0 included to infinity. You saw when I put it in the calculator, it said error, error, error. That's because there's no negatives. It starts at 0, it's included. I did put a solid dot there, and it goes all the way to the right. What's the range of f of x? Okay, well, there's nothing in the negatives. It does start at 0, and it goes up to infinity. So my domain and range happen to be the same for regular old square root of x. Okay, now I'm coming back up to the top. G of x equals square root of x minus 5 plus 3. All right, let's think about what I was talking about at the bottom of the last page. and let's try and guess what's going to happen. Okay? I said number on the inside with x moves the function left or right. So this guy's going to be moved 5 left or right. Well, the inside always does the opposite. So I'm just going to make a note down here and we can check it afterwards. I'm saying that this guy's going to move right 5. Okay, how do I know it's on the inside with the x? Because both the x and the 5 are under the radical. Just like the numbers that were together with the x last time were both in the parentheses. This time, both numbers are under the radical. The plus 3 is the guy on the outside. It's not under the radical. So the number on the outside, going back to my page from before, the number on the outside moves the function vertically. So that number is going to move it up or down. In this case, on the outside, it is as it seems. So it's going to move it up 3 with a positive 3. Okay. I'm going to graph it and see if our theory is correct. I'm just going to come back in here and do -5. I can see that that line is still over it, so I go over to get out and then put a +3 on the outside. Going to my table, lots of decimals. I'm going to come back up here. Oh, there's my errors. Okay, so the first nice point I see is 5.3. I'm going to put that in my table. The next nice point I see is 6.4. Scrolling down again, you can include some decimals in here if you want to have a nicer graph. 9.5. The next nice point I see. 14.6 is another nice point. I could keep going, but I know that's going to go off the graph. So you can see how it goes off the graph, but it's the same shape. 1, 2, 3, 4, 5. 1, 2, 3. There's my endpoint, my new endpoint. It moved from 0 to 5.3. 6.4. 9.5. I'm just going to kind of guesstimate like we're 14. Like this is 10, so 11, 12, 13, 14, and then it would be at 6, so just a little bit higher. That can kind of help me. Just for the point of trying to show you that this graph does look just like the other graph. This guy's g of x. Is our theory correct? Did that guy move right 5 up 3? 0, 0 over to 5? Yep. 0 up to 3. Yep. So before even graphing it in the calculator, you can tell what happens from here to here if you know those two rules. If you know that the number on the inside is going to move it left or right, and opposite of what the sign tells you, so this is right 5. The number on the outside is going to move it up and down, and it's going to be exactly what it seems. +3 is up 3. If this was a -3, it would have been down 3. Okay, part B, what is the domain? Now we're looking at the pink one I have here. So furthest right this thing goes, for this left, I'm sorry, this thing goes is 5. There's no part of the function exists over here. So it starts at 5. I'm including that, and it goes to infinity. It starts at 5 and goes to the right forever. Range. What's the lowest it goes? The lowest it goes, now I'm looking at my y-axis, the lowest it goes is 3, and it goes up forever. Slowly, but it goes up forever. Okay, was there anything I wanted to say after that? I think we're good there. Okay, moving on to number 3. This is really just a domain question, but it kind of reiterates what we've been talking about. It says the graph of the function f of x, square root of x plus 4 is shown. And they're just verifying what we just talked about, that your regular square root graph would be at the origin. This one is moved left 4. That +4 is on the inside. And an inside movement moves it left or right. The fact that it's +4, we do the opposite, so it moves it left 4. So if I'm answering the domain, which is what they want for this, in interval notation, the same way I have for this page and the last page, I would say, I would make a bracket because I'm seeing a closed dot there because it's an endpoint. And I would say -4 is the furthest left it goes. And I would say it goes to infinity. And it's really good to know interval notation. But every once in a while, they throw set notation at you. So you got to know how to translate this to this. Okay, so the X in the line just means X such that. So you're looking to match up this with one of those. I think it should be pretty clear that it's not 0. If they asked for the range, it would be Y, including 0 up to infinity. So they're trying to throw you off with those by putting 0 in there. So it's got to be one of these -4 ones. Well, how do I know which one to pick? The one without the line or the one with the line? The fact that this is a bracket, because that's a closed dot, means we pick choice 4. We want it or equal to. Okay, some of my choices got cut off for this last one, but the right answer still stands, so that's okay. It says, consider the functions, plural, regular old x squared, so that's like my orange one up here, and square root of x plus 4. How was f of x shifted? Well, first thing, is this on the inside or the outside? That is definitely on the outside. So the fact that it's on the outside is going to move it up or down. On the outside, it is as it seems. So this will move it up 4. If I wanted to move it down 4, I would do that. Oops, I was off the screen. That would be down 4. And you have to make it real clear that this is on the outside. If I wanted to move it right 4, I would put that in the inside. That would be right 4. If I wanted to move it left 4, I would put a +4 on the inside. Okay, the only thing that makes this tricky is that when you're looking at the left and right movement, you have to do opposite of what you would think. So a -4 means right 4, a +4 means left 4. And keeping straight that the inside moves it left and right and the outside moves it up and down. Okay, hopefully that helps with homework 6, and have a good one.